Hi everyone, in today's lesson we're going to talk about limits. The goals for today will be to define what a limit is and then evaluate those limits algebraically. For purposes of time, I took the liberty of typing this out, so if you'd like, now is a good time to pause the video and write down the prompts here and then hit resume when you're ready to fill in the blanks. So, a limit. By definition, a limit is a y value that a graph approaches, keyword there, but may or may not reach. So again, a limit is a y value that a graph approaches but may or may not reach. There is a notation or a symbol that we use to define a limit, and it's as follows. We would write it the limit as x approaches some number, and we're going to call that number c. It could be 5, 6, 7, 8. C is just a letter that we use to kind of refer to it as a constant. So the limit as x approaches a constant of f of x. That is the notation when I'm asking you to find a limit. Now another definition is a limit exists at x equals some constant if and only if the limit from the left is equal to the limit from the right. And then the other side, a limit does not exist at x equals c if the limit from the right does not equal, so I'll put a little symbol there, does not equal the limit from the left. And we would write d and e for the limit does not exist. That's what the d, n, and e stands for. This is for the d, n, and e. So a limit does not exist if the limit from the right does not equal the limit from the left. So these are the three definitions that we're going to use throughout the lesson today. So here's an example of a graph. I wouldn't suggest writing this down. The picture is going to be a very challenging, I would say, to draw. So just kind of watch along and see if it makes sense. If you think you can write it, go ahead. So let's analyze this. So this says, I want you to find the limit or the y value. Remember that limit is a y value. So I want you to find the y value of the function, this is f of x, as x approaches -1. And you see this little minus sign on top? That means from the left. So what I actually want to do is take a couple of notes before we even can answer this. So we'll say the limit as x approaches c minus of f of x means from the left. And the limit as x approaches some constant c with a little plus sign next to it of f of x means I want to find the limit from the right. And if I did the limit as x approaches c of f of x without a little plus or a minus sign here, right? See how this has a plus and that has a minus. If I put nothing there, I mean you have to check the left and the right. Okay? So, once you have all that written down, feel free to pause the video until you're ready to continue. Let's now see if we can answer the question. So the limit as x approaches -1 minus means from the left. So on the top of my graph, I always like to write down that this is the left side, this is from the left, and this is from the right. It just helps us with our direction. So I want to approach -1. So here's the x value of -1. Notice it's x. So the limit as x approaches -1 from the left. So follow the graph. I don't care that there's a gap here. Follow the graph until you're at x equals -1. So it's right here. What is that y value? You're going to tell me that it's 4. Okay. Now the second question, same thing. Limit as x approaches -1, but now this plus means from the right. So go to the right of the graph, follow it. Again, I don't care that there's a jump, just keep following it. And we're at -1. What is that y value? You'll tell me 4. So the definition of a limit now I want to find the limit as x approaches -1. Notice how there's no plus or minus. That means you have to check from the left and the right. If the left and the right are equal, then the limit exists. If the left and the right are not equal, then the limit does not exist. So, if we look, the limit from the left and the limit from the right are both 4. So if you look here, the best way to explain it is this is the limit from the left, this is the limit from the right, and they both meet at that same y value, therefore the limit exists, 4. And basically what this means is evaluate the function, find f of -1. So we're at -1, what is the y value? That value happens to be 4 as well. So all 4 of these answers are 4. All right, let's try another section of the graph. I want to now find the limit as x approaches -4 minus, so -4 from the left. So here's from the left side. Approach the x value of -4 from the left. What's the y value? You should be telling me 3. Now the same thing, but now I want the limit as x approaches -4 with the plus means from the right. So find x equals -4 from the right, which is down here. What's that y value? -2. So notice that this is an open circle, and I still wrote the limit of -2. A limit is a y value that it may or may not reach, or may or may not equal. So a limit can have an open circle. That is totally fine, therefore the limit is -2. So if you notice, the limit from the left is up here, and the limit from the right is down here. Are they at the exact same spot? No. One is 3 and one is -2. So when I'm asking for the whole limit as x approaches -4 without a plus or minus, you have to check the left and the right. So if the left and the right are not equal, then this whole limit does not exist. So the best way that I can explain does not exist just means if they don't meet at the same point. So you see how this one met at the same point, the left and the right? It met at the same point. It exists. This left and this right don't meet at the same point because there's gaps in between. So that's the main difference. All right, so now the hard part for this one is to evaluate, find f of -4. So you go to the x value of -4, and how do you decide which y value to pick? Do you pick the 3 or do you pick the -2? And the answer is you always pick the closed circle. You pick 3. Because the open circle would mean that there's a hole in the graph and that it doesn't exist there. It's really just not there. So we have to use closed circles. So if you want to write a couple of notes, these guys, D, H, and L, if you want to put a little star, they must use closed circles. Okay, when you're evaluating the functions f of x. Limits can have open or closed circles. I can even write that up top here. Limits can have open or closed circles. And that's because the definition of limits is it may or may not reach. If it does reach, it's closed. If it doesn't reach, it's open. All right, let's try another one. So the limit as x approaches 4 from the left. So here's 4 and from the left. So follow the graph. 4 from the left is this way. What is that y value? You should be telling me 2. Now the limit 4 from the right, here's the right side of the graph. What is that y value? The y value is 2. Again, it's okay that it's an open circle. So therefore, if I'm asking you the limit as x approaches 4 without anything, I have to look at the left and the right. Since they are the same, the limit exists and the limit is 2. And this is where it gets a little tricky. If I want to find f of 4, I look at the x value of 4 and I look up to find a y value, but I must be looking for a closed circle. So since there are no closed circles, then it doesn't technically exist, and we have to write undefined. So we use, if it helps, I'll write it over here, we use D and E for limits, and we use UND, or undefined, for f of x values. So these are the things that I would definitely suggest that you write down, because you can easily confuse DNE with undefined. So we use undefined when I have f of values, and I use DNE when I'm asking to find a limit. It's just proper notation. Okay, I know that was a lot, but let's try another one. I think the more that you do, the easier it'll be, and it'll sink in more. Okay, so here's a different example, same kinds of concepts. What you should notice, what's different about this picture, is that I have asymptotes. This is a horizontal asymptote, and this is a vertical asymptote. So this graph is approaching that asymptote, and the graph here and here are approaching the vertical asymptotes. So I want to find the limit as x approaches -2 plus. That means from the right. So if it helps, I'm going to put left over here, and I'm going to put right over here. It's always helpful. And I want to see as x approaches -2. So here's -2. Here's from the left. What is the y value? Right here, -2. So if I just put a little arrow here, this was the limit from the left. The limit from the right would be here, which this y value here we'll estimate is -1. So again, for part C, if I'm asking the limit as x approaches -2 without a plus or a minus, I'm asking from left and right. Notice how they're not meeting at the same point. There's a gap. Therefore, the limit does not exist. Can I find the value of f of, this is a typo, this should say f of -2? Can I find the y value? Absolutely. So here's -2, the x value. So I look for the closed circle, which is right here. So that y value is -1. So remember, f of x, we're looking for closed circles. If it's not a closed circle and it's open, then we would say undefined. Okay, when I'm asking for f of something, all right? All right, so part E, the limit as x approaches 8. So 1, 2, 3, 4, 5, 6, 7, 8 right here. The limit as x approaches 8. If you notice, there is no plus or minus. So what that means is you have to know to check both sides. So the limit from the left and the limit from the right, do they approach that same y value right here? They absolutely do. That y value we'll estimate and we'll say it's 2. So again, limits can have an open circle. It's a y value that it's approaching. But now notice, if I'm asking you to find f of 8, that's what's the y value when x is 8. So when x is 8, what's the y value? We look for a closed circle right up here. That would be my y value. So let's count. 1, 2, 3, probably 3.5. Doesn't have to be perfect, but that's the idea. What is the y value? All right, let's try G. The limit as x approaches 2 from the right. So here's 2. We're on the asymptote. So from the right, if this is x equals 2, from the right is going down. From the left is going up. So from the right, if it's going down here, we say that goes down to -infinity. If from the left with the minus sign, it's going up to positive infinity. So therefore, if I want to take the limit as x approaches 2 without a plus or minus, notice the limit from the left and the limit from the right don't meet at the same point. They're opposites, therefore the limit does not exist. And if I want to find f of 2, here's my x value of 2. I'm looking for a closed circle. Well, I don't see any. It's on an asymptote. So if I don't have a closed circle and it's open, or in other words, we could say if it's at an asymptote, then it's still undefined. So remember, we use undefined for f of values and DNE for limits. All right, the last two questions I have are the limit as x approaches -infinity. So as x gets really small, 1, 2, 3, 4, negative, all the way around here, as x goes to the -infinity, right? -infinity would be somewhere over here where it is happening to the graph. So you got to follow the graph here. The graph, you can assume there's an arrow, is going all the way to the left, but it's staying on this y value. So again, what's the y value for the limit? The y value is -2. All right, same thing for this one. I want the limit as x approaches positive infinity. So if this is positive infinity, I have to follow the graph. Where is the graph headed as I move to the right? As I go to the right, where is this graph headed? We look at this y value here. We're assuming that this is an asymptote and this is approaching it. So it approaches this y value, which we'll say is about 2.5. All right, so this one I'd actually like you to try on your own. I would pause the video and then hit resume when you're ready for the answers. All right, this is what I got. All right, that's it for today. If you have any questions, please let us know. Have a good night.